Hello, I believe this is the last part, which is questions 9 through 12. And question 9 is to find true or false for a through h. So, a is the sequence of cosine of n pi over 2, and we have to test if it is convergent. And we will just write out true or false. So, to test this, we can just write out some of its values. When we plug in 1, we'd get 0. When we plug in 2, we'd get -1. When we plug in 3, we get 0. When we plug in 4, we get 1. And it looks like we are alternating between these values. So we get 0, -1, 0, 1, 0, -1, 0, 1, and so on. So, since this does not lead to a value, we can say that this is false. Next, the sequence -2 to the n over n is monotone. And we can test this again by plugging in values. With 1, we get -2. With 2, we'd get 4 over 2. And with 3, we'd get -8 over 3. And we can stop right there because we can see that we are increasing and decreasing, which means this would also be false. Now we need to see if the natural log of 1 plus 2 over n converges. And when we plug in our values, we would get 1.09 for n is equal to 1. For 2, 0.693, then 0.510, then 0.405, then 0.33, and then we would eventually get to 0.154, and we can say this is decreasing and decreasing and decreasing. We can say this is going to go to 0. So this is true. Next, the sequence cosine of 1 over 2n is convergent. So let's start plugging in some values. At 1, we get 0.87. At 2, we get 0.96. 3, we get 0.99. At 4, we get 0.99. At 5, we get 0.999. 6, we get 0.999. At 7, we get 0.9999. And we can say that this will eventually reach 1, which would make this convergent, meaning it's true. And the series 1 over 2n is convergent. Again, we can plug in values. So we would get 1. When we plug in 1, we get 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus blah blah blah. And this would give us a total sum of 1, which would mean it is convergent and true. Sorry, I mixed those up. The series sine of n pi is convergent. Again, we can test out some values. And we can already see any value at pi for sine is 0. So this would just be equal to 0, which would make this true. Now they're saying that this series 1 over n times n plus 1 is equal to 1/2. And if we just plug in some numbers, starting at 1, we get 1/2 plus 1/6 plus 1/12 plus 1/20th. We can already see the value will be at least bigger than 1/2, so we can say this would be false. Lastly, they are saying the series x to the power of n is equal to 1 over 1 minus x. And we know this is true because this is a geometric series, and the value of a, which would be the coefficient of x to the n, is 1, and the formula looks like 1 minus r, where r is equal to x. So yes, this is 1 over 1 minus x, making this true. Alright, now we have to consider the series -1 to the n times 4x to the n, using the appropriate test to find the radius of convergence and the interval of convergence. So, first of all, we can say that this is equal to -4x to the n. And we can go ahead and find some values. Starting at 1, we get -4x plus 16x squared minus 64x cubed plus next. And since this is raised to the nth power, we automatically know to use the root test. For that, we take the limit as n goes to infinity of -4x to the n, absolute valued, to the square root to the nth square root. That would equal to limit as n go to infinity. The n and the n cancel out, and we would have 4 times the absolute value of x, which would be equal to 4 times the actual value of x. Now, we need to find out what happens when x is equal to, when 4 to the absolute value of x is equal to 1, is less than 1, and greater than 1. So when 4 to the value of x is equal to 1, and 4 to the value of x is less than 1, and 4 to the value of x is greater than 1. All we have to do is solve for some values of x by dividing each side by 4. So the absolute value of x would be equal to 1/4. The absolute value of x would be less than 1/4. And the absolute value of x would be greater than 1/4. Whenever the absolute value of x is equal to 1/4, we don't know if it's convergent or divergent. So, I don't know. Whenever it is less than 1/4, we could say it is absolutely convergent. And whenever it is greater than 1/4, we can say it's divergent. Now we can draw this on a graph. We can say this is the point 0. This is -1/4. And this is 1/4. Since we know the radius of convergence, which we got from finding those, is equal to 1/4, we start at 0 and went both sides 1/4. So we know that this is all convergent. And we know that these are all divergent. Next, we need to find if the values of -1/4 and 1/4 plugged back into the series is divergent or convergent. So we can say series is equals n to 1. We'll start off with negative 1/4. Negative 1/4 times negative 4 is negative 1, which would be negative 1 to the n. And we'll go ahead and write the next one. 1/4 times negative 1/4 to negative 4 is 1. And this would be negative 1 to the n. We know that negative 1 to the n, that's equal to 1 plus 1 plus 1 plus 1 plus 1, all the way to infinity, making it divergent. And we know this is negative 1 and plus 1 and negative 1 and plus 1 and negative 1 and plus 1, and that would mean this is also divergent. So we can say that at 1/4 it's divergent, and at negative 1/4 it's divergent, making the interval of convergence equal to the open brackets 1/4, negative 1/4 to 1/4. Next, question 11. Convert 1, root 3 and 1, 1 from rectangular coordinates to polar coordinates. This is fairly easy. We can actually use a calculator to do this, but if you don't know how, to convert from rectangular to polar, we use the equation r squared is equal to x squared plus y squared, and theta is equal to tan inverse of y over x. So we will take this 1 and root 3, and we can say r is equal to square root of 1 squared is 1, root 3 squared is 3, and we can say that means r is equal to square root of 4, which would mean r is equal to 2. And we can say theta is equal to tan inverse of root 3 over 1, and that just means that theta is equal to pi over 3. So the first coordinates would be 2, pi over 3. Next, we can say r is equal to 1 square root of it is 1, 1 square root of it is 1, square root, r is equal to square root of 2. Theta is equal to tan inverse of 1 over 1, which would make theta equal to pi over 4. So our next coordinate is square root of 2 over square root of 2, comma, pi over 4. Next, for second part of 11, we have to find the area of one loop of the four-leaved rows. R is equal to cosine 2 theta. So we know whenever the coefficient in cosine is even, that means the leaves will be double, and we already know that from this four-leaved right there. We also know that cosine doesn't start, but it loops around that fourth and first quadrant, where sine would loop around the first and second quadrant first. So we can say that the graph would look something like this. Let me draw my there we go. Oops. Oh wow. Okay. You can also find the values of the points by plugging in values of theta. But since we want to find the area of one loop, we can say this area right here, which would mean we want to find these limits, which would be negative pi over 4 and pi over 4. So we can say the area is equal to the integral of negative pi over 4 to pi over 4. And to find the area of a parametric equation, it's 1/2 r squared d theta. Since this is an even function, we can actually make this a 2 over 2 if we pull out this coefficient from 0 to pi over 4 r squared d theta. However, I prefer to stick with the negative pi over 4. So we're going to say we have 1/2 negative pi over 4 to pi over 4, and r squared is just cosine squared 2 theta. D theta. And the integral of this, we need to split up that power by using a power reducing formula. So we can say the integral of 1/2 1 plus cosine of 4 theta d theta. And this would be equal to 1/2. We can actually pull out the coefficient, so 1/4 times theta plus sine of 4 theta over 4. Evaluated from negative pi over 4 to pi over 4. And if we evaluate this, we would get 1/4 times pi over 4 minus negative pi over 4, which would be equal to 1/4 times pi over 2, which is equal to pi over 8. And that would be the area of one loop of the 4-leaved rows of cosine 2 theta.